Hey guys, it's close to noon on Wednesday, and what I did is at this current time, I pulled the questions that I saw you guys had most missed and wanted to talk about them. So if any of these 4 questions you had questions on, I'm going to talk about how to do each of them right now at this time. Sorry that they're all different sizes, and I don't know, for those of you that are, perfectionist type A. Wait, what? I'm talking about myself. So anyway, question number 8 and question number 6 are very common missed questions. And I think a big part of the reason people miss these is because they forget to think about what quadrant the given ordered pair is in before they even begin the problem. So if you think about number 8, this is X, this is Y. If I were to graph this normally, I have a negative X value and a positive Y value, you're talking about quadrant 2. So before you even do any of this, think about angles that fall in quadrant 2 for this. We are going to be able to eliminate 2 of these answers, and it's going to have to be either A or C. So right there, we can eliminate 2. Now, from there, I can show you the work for actually finding that angle. Remember that that's when you do the tangent of theta and you divide the 2 values. And when you divide these 2, notice that it's the same quantity. You would divide and get a quotient of -1. Well, remember, that would have to happen in one of these 2 quadrants where you have one of the values being negative, one of the values being positive. So it makes sense that we would get this angle of 3 pi over 4. Now, to get the actual R value for this, remember that we are going to square the X and Y value. So when you're squaring this X value of -5 root 2, and then you're going to square the Y value of 5 root 2. Note that when you square a product, you can square each of the pieces. So that would be 25 times 2. And then same thing over here, 25 times 2. So what you're going to get for R squared is 100. And then an R value equal to 10. So that's where we get this answer for C, or of C for number 8. Now, going to a question just like that, this is the same idea. And honestly, the biggest part is just identifying what quadrant this is in before you begin. A negative X, negative Y. You have to be in quadrant 3. So right away, we can eliminate this answer and this answer. And it appears that that was the biggest problem here, is just choosing between B and C. Now, why would it come down to B and C? Well, think about it. When you find the tangent of theta and you divide these 2, you're getting 1. But there's 2 places the tangent of theta equals 1. When you have 2 positives and then when you have 2 negatives. And that's why we can... Hey, Spencer, I'm doing a video right now. Come here. Do you want to say hi? Yeah. Come here. Say hi to all my students. Say hi.
Hi.
They can't see you. Tell them a story. Who's your favorite Avenger? I know it's tough. It's tough. Who's your favorite Avenger? Oh, you don't have to be shy. They can't even see you. Okay, can you give me 5 more minutes?
I like to look at.
Okay. Here, go play with Brooklyn, okay? Okay.
Hi-yo.
Say hi to all my students.
Hi.
Hi. Okay, go away.
No.
Love you.
No.
Go away, Quesadilla.
No.
Go away.
No.
All right, glad she listens. So then obviously that would get us to that angle of 5 pi over 4 in the third quadrant, because again, both X and Y have to be negative. So that's where we can get that answer right there. Moving down to the next question with dot products. Well, remember that we have this formula that says the cosine of theta is going to equal the dot product of U and V over the magnitude of... Okay, let's try this again. I'll do the formula as you guys learned it. Dot product of U and V times the magnitude of U, magnitude of V. I just realized, though, in this problem, why I kind of paused that way, is that they're using V and W. So I'm just going to adjust this formula to this problem. So that's that, and then that's that. Now, they gave us the angle as 240, so let's fill that in. Cosine of 240 is going to equal this dot product, which we're actually trying to solve for, over the product of the magnitudes, which we're told is 6 and 8 for each of them. So that product would be 48. Now, cosine of 240 is a quantity that we can find. If we're right here, 240 degrees, and I say the cosine, that's the x value, this whole quantity equals negative 1/2. So as a result, I can use cross multiplication and get negative 24 equals W dot V. And that's exactly what we wanted to find. We wanted to find the dot product of those two. So that would give us that answer of negative 24. Now, final problem on here is about, actually very relevant to how I feel lately, but it's about my children all grabbing me and pulling me in different directions. I do not have 3 arms, so let's just assume that they are grabbing my shirt or something like that. But we have one child pulling me due east. We have another child pulling me due south, and my final child pulling me due west. Mr. Schmer is going to also pull me, but in such a way that I'm not moving in any one direction. So in other words, I'm in equilibrium, which I'm sure you guys are all visualizing this. And again, it is very, very great problem to really think about in these times. So I'm going to draw a quick compass, and I'm going to have my north, my south, and my wee. So thinking about Brooklyn pulling me due east, if you think about creating a vector for this for Brooklyn, you can obviously use the angle of 0 degrees to represent due east, and you can set this up as 15 cosine 0 degrees, and then 15 sine 0. But we know what the cosine of 0 degrees is. We know what the sine of 0 degrees is. So this whole quantity becomes 0, and this whole thing just becomes 15. Now, for McKenna, she is pulling me due south, and she is, what are we at? 12. So we have 12 here, cosine, and think due south would be 270 degrees, and then we can do that same thing with the sine. Now, cosine of 270, 0, so this whole thing becomes 0, but sine of 270 is negative 1, so this becomes negative 12. And then finally, Spenceman, he is pulling me with 13, and it said he was going what? West, so that means that I would use cosine 180, and then I can do 13 sine 180. So what we end up getting here is a negative 13, and over here we get a 0. Now, I want to add in Mr. Schmer. Let's use a different color. So, Mr. S. And he is going to pull me in such a way so that when I add up all of this together, I get a 0 here and a 0 here. Now, when you think about it, you can just do some math with this, and you can think about how we have a 15 and a negative 13. So when that adds together, that's going to give me a quantity of 2. So we need to make this negative 2. Over here, I have all of this added up to negative 12. I need to add that with a 12 to get 0. So this is really what I'm looking for here. Now, that gives me the component form for Mr. Schmer, but I need his tension force and the direction angle. So remember, from here, to find that tension force, what I can do is I can find the magnitude by taking the square root of negative 2 squared plus 12 squared. So that's going to give me a 4, a 144. So I want the square root of 148. Let's get my calculator. Oh, there's the quizzes that I just pulled up. Oh, what am I looking at? Let's see. So we can find that value. So square root of 148. And we're getting approximately 12.166. And that would be the first part of the answer. So that's this part right here. And then we need to find that direction angle. So with the direction angle, if we want to find that, we're going to say that the tangent of theta equals 12 over negative 2. Remember, y over x. So if I want to find theta, I'm going to do the tangent inverse. If you hear that in the background, my children are watching a really weird show right now. That's not actually my children. Oh, you know what? Sorry. Before I do this, let me make sure I'm in the right mode. So I want to be in degree mode and then do that again. So I'm getting this answer right here, which obviously is not what I want, because when you think about the component form of this, again, like I was just talking about, think about this quadrant. You're going in the x direction 2, but to the left, and in the y direction up 12. So really think about a quadrant 2 angle. I would have to take this answer and add 180, and that's getting me that 99. Got 99 problems, but math ain't one. Okay, and that would get me to that final answer for part B. So let me know if you have any other questions. Hopefully that helps you with the 4 questions that I noticed were most missed. And good luck with your work for today.